Hi guys, got a little interesting project here, and it started out with this, the Arctic F12 PWM PST. That's this ventilator, and it's an interesting one. It's Rev.2, revision 2 of a previous product by Arctic Cooling. Now, I've got a wide assortment of ventilators here. A Silverstone, this is a Zelman, got another Zelman here, and also two previous, Arctic Cooling ventilators. They're all for computers, and that's very nice. Now there's something funky going on with this revision 2 by Arctic Cooling, and for that I'll have to explain a little bit. So let's get a drawing made up in this video. So some common dry theory, which is interesting to know because then you know what to look at when you're buying. Well, these don't attach, but common fan headers. Yeah, that's hopefully legible. And this is very interesting. They're always electrical motors, and you need at least a 2-pin connection, which means a plus and a minus. This is the most standard and one of the oldest connections for computer case fans. Just a plus and a minus, and well, normally they're connected to 12 volts and negative earth or negative, that's it. After this connection, the two nice pins on a motherboard, the plus and the minus, was invented, quote unquote. They developed a 3-pin connection, and that included the plus and the minus and also an RPM signal. Now you might wonder, of course this is 12 volt and this is negative. Now imagine you have your 3-pin connection on your motherboard. They transmit power via one cable, and let's grab another one, and let's first make a little ventilator. And I'm not sure how well I'm able to draw this, but let's say that's a ventilator. 2 blades balanced nicely, very well. A negative, a positive, and a third connection that's called the RPM signal, and that one is yellow, and hopefully you can see that. You might not be seeing that as well, so I'll grab another color. It is a yellow cable normally, but let's make it orange for the camera. There you go. Now there's something very funky going on with this signal, because it is in fact not sending a signal, but receiving a signal back from the motor. And that's the interesting. It is a return signal that denotes the current RPM. And that is basically an invention to allow a motherboard to better control the speed of the ventilator. Because, a motor of a ventilator can run on 12 volts, but it usually has a lower starting voltage. So basically, let's draw a little motor here with an axle coming out here. Let's say motor. It has a starting voltage and a max voltage. And the funny thing is, well, it isn't linear, but let's draw it linear. Basically, the higher the voltage, this is 0, the higher the voltage, the higher the RPM. So there's a starting voltage. So let's say, well, it doesn't start but from here, and then it goes up. So I can't really remove this, but you get the idea. So this is more as well as this is more. So motherboards can control the speed of a ventilator with a 2-pin connection, but there's a problem. They don't know for sure how much RPM or how fast the blades of the ventilator are spinning. So that's where that 3-pin connection comes in with a return signal. So the current RPM is reported to the header of the motherboard. If it is, of course, connected to the motherboard. Now this isn't the only one. There's also a 4-pin connection. And this is even more interesting. That is the plus minus RPM. Well, that's a bad M, but let's say some voltage. Well, that's not true, because in a 4-pin connection, a PWM connection isn't some as it is here. So let's say plus minus 5 to 12 volts. No, it is 12 volts. Well, double V, but you get the point. 12 volts. Negative RPM return signal, but there's a 4th connection, and that is the PWM signal. Okay, we're drawing almost. Let's do it like this. So the PWM signal is pulse width DTH, I think. I'm Dutch, so most likely that's misspelled. Width, at least. Modulation. So, pulse width modulation is a technique in which there is, well, 1, 2, 3, 4, right? So we've got basically the same idea. The fan. Ooh, that one just right. But you've got the positive signal, the negative signal, and of course not in orange but in yellow, the RPM return signal. And there is another color, and which is it? Let's check. Oh, it's blue. That's nice. And there's a blue cable. And the blue cable, let's use the P. Well, that went horribly wrong, but PWM is a send signal, right? It instructs the electronics of the motor to turn at a specific speed. And this is very interesting because with this you have high granularity of speed control of the motor of the fan. So PWM, if I'm correct, it is basically just a normal signal with a certain interval. It's very simple, but this doesn't really matter. It just, let's say, allows speed control of the motor from, let's say, a setting of 0 to 264. I think that is correct, at least. This isn't relevant. Let's write that down. Irrelevant. Right? I'm not sure, doesn't matter. But what is important is that 4-pin connector, the plus minus, the return signal of the RPM and the send signal of the PWM allows high granularity control of the fan motor. Right? Now this all depends on basic cable logic. A 2-pin connection is very simple. You plug it in, right pole to the right connection terminal, so plus to plus, minus to minus, and the fan starts to spin. And with this you can also tune it down, although I think most older motherboards don't support that. But let's say this is also plus minus 5 volt to 12 volt. Negative is of course negative. Now, the motherboard with RPM signal return can determine, let's step down the voltage because the user has enabled in the BIOS a lower setting than the 12 volts that a fan can run at maximally. Right? But this is dependent not on one plus or one minus cable, it is dependent on all four. And I'll grab this one. Let's put this away for a little bit. And look at this. Now, this cable has 1, 2, 3, 4 colors: black, red, yellow, and orange we use basically, but yellow and blue. So this is negative, positive, RPM, signal return, and PWM, signal send. So signal send from the motherboard to the motor. And this is a very interesting cable. Let's grab a more common one. Right, that's this one. This is from Silverstone. It's just one cable. Right? You plug it in and that's it. The electronics that's built on the little circuit board behind this thing detects the PWM signal if your header is 4-pin and it supports it, and basically runs the speed that it is requested of, or at least runs the motor that it is in the speed that it is requested of. And I'm very interested in this one because in this cable there are just 3, I repeat, 3 cables really going to the motor. There's a 4th one, the RPM return signal right here. So if I hook this up to a 2-pin connection, it will run at the set speed that the motherboard is set at. So somewhere from 5 to 12 volts. If I use a 3-pin connection without plugging the return signal in, it thinks it's still a 2-pin connection. Now, if I plug it in, like so, the motherboard gets the return signal because that runs via this yellow cable. That's not included in this, right? Now, if I plug this in like this into a 4-pin connection, the high granularity control of the fan speed is enabled. If the motherboard supports it, there are a couple of prerequisites, but basically that's it. This is all very interesting. because I'm not obliged with this system to plug this RPM signal return cable into this. I can use, let's say, this one, and daisy chain basically a very similar cable on this one, and right at the moment the motherboard, which let's suppose I plug this plug into, is still not getting an RPM return signal. But I can select with this nice system from Arctic Cooling, I can select which of the ventilators I'm using is the dominant one. And the one the motherboard will detect in the sense of return signal, RPM return signal. And in most instances, you would in fact hook this one up to the one that is connected to the CPU cooler. Right? Return signal from the CPU cooler. And why is that? Because, well, most CPU coolers have a lot of surface area in the sense of fins, which have to, allow air past it, and the more resistant you have on those fins, the slower the ventilator will try to turn or be forced to turn because of resistance, air resistance. The more power this thing needs, or at least, something like that. I'm not completely truthful here, but that's the sense why in normal circumstances you want to return the return signal of the ventilator that is attached directly to the CPU cooler. This signal, let's say I've got this one mounted to the CPU fan. I would then of course untie this, but plug this one in the end of this daisy chain, and you can chain up a number, a limited number. Check your specification, know what you're doing, but you can daisy chain a number of these ventilators together and plug in the last one, this. And that would be very nice. I could even say I'm just using these Arctic Cooling, ventilators for my case, and use something like this, a PWM enabled, ventilator from a different brand. Brand. Well, you get the point. And plug that one in. In this case, in this daisy chain, the PWM signal would reach all of the ventilators, but only the RPM return signal of this ventilator would be reported via this daisy chained cable to the motherboard. Because, let's unplug this. But here is the yellow cable under the sleeving. It's that simple. Now, this is a wonderful system. I like this. It's very simple, elegant, and as long as you keep within the bounds of the technical limitations of a motherboard header, basically all those fans you hook up, I say max 3, perhaps 4, dependent on how much current they draw, but they will get controlled by the motherboard header that supports the PWM and automatic, temperature control of the CPU. So basically, if your CPU gets hot, it will try to enable, with this signal daisy chaining of the return signal, it will try to ensure that the ventilator that's attached to the CPU cooling block runs at a certain speed. And the case, if you mount these to the outside of the case, they will try to match up and try to blow air through the case, which is nice. Now, I like this system. I like this system a lot. But, there's a big but. The new cable doesn't do that. The revision 2. Because, let's unplug this and compare properly. Right? The new cable is a comparable, at least in the sense that there's something wrong here. And let's see, well, the colors are not all that correct. But what's going on here? What's wrong here? I'm seeing, well, let's yeah, flip it around and flip it around again. Left is new, right is old. Okay. They've got black and red is now black and yellow. The green one was yellow, so that's the RPM signal, return. And the blue one, well, that's of course the PWM signal. So if you're daisy chaining in the old system, you determined by plugging in the yellow RPM cable, so the RPM return signal, you determined which one that was by plugging it into the last female socket in the daisy chain, right? With this one, well, basically the first ventilator in the daisy chain determines the return signal for RPM. So the signal, the return RPM signal that is reported to the motherboard. And I've got 3 of these things. And to be frank, I wanted to be able to use, let's say, this Silverstone as the dominant RPM signal source. Well, if I plug it in like this ventilator will be the dominant one and not the Silverstone. And that's not good. In essence, in my opinion, my limited opinion, this new iteration of this wonderful system will force you into buying basically an Arctic cooling cooler plus ventilator that has this pass-through system as it is here. So I think they call it the Rev.2, but at least this ventilator is revision 2. I haven't seen this yet. I bought 3 under the impression that I would get this system. So this isn't ideal. I would like to see the return of this, although I understand, let's put these away. You have a loose cable when you're not using that specific fan as the RPM source, just doing it like this, right? Okay. Now they do sell, to mitigate this, I think, perhaps they already sold that, but they're selling at the moment a little cable tree, like the daisy chain, but they're selling a little cable tree which daisy chains that for you. So basically this little plug becomes almost mute in that system, but it's the same idea. You've got the plug that goes into the motherboard, 4-pin, and the first exit socket is like this one, a complete set. Hey, it is what it is. In that case, with that cable tree, let's show you that again, but the complete set of 4 cables is included in that, in the first, well, what do you call it? Well, it's a paternoster system, so basically in the first side branch. The second, the third and fourth plug don't have the return signal of RPM on that, and that would mitigate the problem I'm having with this, but I'm buying this for a nice and sleek and elegant system of daisy chaining the appropriate number of basically ventilators. So this is basic computer theory in regards to computer ventilators, but this old system is handy. it is effective. It doesn't force you into buying additional stuff. It doesn't force you into buying an Arctic Cooling CPU cooler that supports the new system, because it allows you to plug in as the last chain in the daisy chain any type of ventilator that supports PWM. I'm a bit disappointed, because a revision is normally something that enhances a product, not detracts from it. And this Arctic Cooling F12 PWM PST system isn't an enhancement. It's almost a vendor lock-in, in my opinion. I like the old cables like this, even though you had an extra cable hanging around, because you can tie it off like this. This is a technically elegant system. And PWM is basically that. The control of the ventilator is not done by regulating the voltage going to the ventilator. No, it's done by the PWM signal. And that's a bit of dry motor theory that I'm not going to do in this video. It is interesting, you can look it up yourself. But PWM is granular control, very nicely done. And this new ventilator from Arctic Cooling just doesn't do it properly, because you must have, in essence, without doing any do-it-yourself cable hacking, which I don't recommend, because you can basically burn your house down. But because of this, the fact that they don't allow you to properly select the return signal, well, it isn't as good as the product used to be. And I'm a bit disappointed. I had to order these in, and well, it is what it is. So I hope you found this now lengthy video very interesting, especially the explanation of this, because this is just a case study for now at least, but this is how this works, and this is how computers get cooled, at least with electromechanically driven ventilators. Well, not this one, because this one is going back to the shop. I did use this one, so with that one, right? Dislike this video at your pleasure, subscribe to the channel, and well, see you in the next video. Bye bye.